Good morning everyone. Myself Mr.Ramkumar, PGT Maths from Telangana Social Welfare Residential School, Kondur Boys, Rangareddy district. Today we are going to discuss about the polynomials concept. In the polynomials concept, we discuss about zeros of the polynomials in detail. Before going to discuss about the zeros of the polynomials, first we discuss about the uses, the meaning and the definition of the polynomials. Later we discuss about the zeros of the polynomials. First we discuss about the uses. Some people uses polynomial concepts without conscious, but most of the people uses the polynomial concept with more conscious. Let me explain with one example. Usually we use it to go to stationery shop to buy some notebooks and pens. For example, now I am going to buy 3 notebooks and 2 pens. Without seeing the price list, I can get, by letting the cost of a notebook as X and the cost of a pen is Y, I can get 3 times of X means 3X and means plus 2 times of Y means 2Y. That means you are ready with an algebraic expression 3x plus 2y. By substituting the value of the notebook and the pen, we can get the final bill. Okay, this is the way we are going to use polynomials in day-to-day life. Similarly, an engineer uses polynomials concept while constructing the roller coaster and when modeling the curves. Similarly, medical researchers, to describe the bacterial colony's behavior, they use polynomials concept, and to predict and to describe the traffic patterns also we use polynomials concept. These are main uses and we can use in many day-to-day life situations. Now we discuss about the meaning of a polynomial. Polynomial is a word derived from two Greek words called poly and nomial, where poly means many, whereas nomial means terms. So it is said many terms. A polynomial can contain any number of terms but not infinite. Now we discuss the definition of a polynomial. A polynomial is an algebraic expression which contains the sum of the terms of the form a x to the power of n, where a is a non-zero real number. That means a not equals to 0 belongs to real number and n, the exponent, should be belongs to whole number. Example, 3x square plus 5x plus 2 is an example for polynomial in one variable x. Now I am taking 7 root x. Is it a polynomial? No, because it can be written as 7 into x to the power of 1 by 2. Here the power 1 by 2 is there. It is not a whole number. Therefore, it is not a polynomial. Similarly, 5 by x. Is it a polynomial? No, because here it can be written as 5 into x to the power of minus 1. Here once again the exponent is not a whole number. Therefore, 5 by x is also not a polynomial. Next, notation of polynomials. Polynomials are denoted by p of x, where x is nothing but a variable, or f of x, or f of y, so on. Example, a polynomial p of x is nothing but 3x plus 5. Here x is a variable, therefore it is denoted by p of x. Now we discuss about the degree of a polynomial. The highest power of the variable in a polynomial p of x. The highest power of variable x in a polynomial p of x is known as the degree of the polynomial. Example, 3x square plus 5x plus 7. It is a polynomial. In this, x is the variable. For x, the power is 2 here, whereas power is 1 in the second term. There is no x, therefore the power of x is 0 here. Out of 0, 1 and 2, which is the highest number? 2. Therefore, the degree of the polynomial here is 2. Based on the degree of a polynomial, there are some names for the polynomials. If the degree of a polynomial is 1, then it is called linear polynomial. Degree 1 means it is called linear polynomial. Example, 3x plus 5. Here x is the variable. For the variable, what is the highest degree of the power? 1. Therefore, it is called linear polynomial. Similarly, an expression containing the degree 2 is called quadratic polynomial. Example, 4x square minus 5x plus 6. Here the power is 2, the highest power is 2. Therefore, it is called a quadratic polynomial. Similarly, a polynomial of degree 3 is called cubic polynomial. Example, 5x cube minus 7. Here the highest power is 3, therefore it is an example for the cubic polynomial. The general form of a linear equation in one variable x is ax plus b. The general form of a quadratic equation means the power 2 is ax square plus bx plus c. Similarly, the general form of a cubic equation is ax cube plus bx square plus cx plus d, where a should be not equals to 0 and it might belongs to real numbers. A should be not equals to 0 and it should be belongs to real numbers, and x is called variable here. If a is equal to 0, then what will happen? In the cubic equation, if a is equal to 0, then the whole term will become 0. Therefore, it will become to quadratic equation. So, a should not be is equal to 0. Now, we discuss about the value of a polynomial. P of k is called the value of the polynomial p of x for x is equal to k, which belongs to real number. Example, 3x plus 5 is a polynomial, linear polynomial. In the place of 3, in the place of x, I am substituting 2. In the place of x, I am substituting 2. Therefore, 3 2s are 6 plus 5. 6 plus 5 is 11. Here 11 is called the value of the polynomial 3x plus 5. 11 is called the value of the polynomial 3x plus 5. Similarly, for this polynomial, in the place of x, I am substituting 1. 2 into 1 square plus 3 into 1 minus 5. 1 square is nothing but 1. 1 2s are 2 plus 3 1s are 3 minus 5. 2 plus 3 is 5 and minus 5. 5 minus 5, 0. Therefore, here 0 is called value of the polynomial. Value of the polynomial. Which polynomial here? 2x square plus 3x minus 5. Now we discuss about 0 of a polynomial. Now we discuss about 0 of a polynomial. A number k is called 0 of a polynomial if p of k is equal to 0. Example, Example, now you can see this one, 2x square plus 3x minus 5. In that we substituted 1. The result, how much we got? 0. Here 0 is called the value of the polynomial, but the substituent number 1, is called the 0 of the polynomial. 0 of 2x square plus 3x minus 5. Here 0 is called the value of the polynomial and 1 is called the 0 of the polynomial. Now we are going to take one more example to find the 0 of a polynomial. I am taking a polynomial p of x, which is x square plus 2x minus 15. In the place of x, I am substituting 3. That means p of 3 is equal to, in the place of x, I am substituting 3 means you will get 3 square plus 2 into, in the place of x, we are going to substitute 3. So into 3 minus 15. 3 square is nothing but 3 into 3, which is nothing but 9, plus 2 3s are 6 minus 15. 9 plus 6 is 15 minus 15. 15 minus 15 is 0. Here 0 is called value of the polynomial p of x. Whereas 3 is called, the substituted number 3 is called 0 of the polynomial p of x. A linear polynomial contains only one 0. Whereas a quadratic polynomial contains at most 2 zeros. Similarly, a cubic polynomial contains at most 3 zeros. Now we discuss about how to find the 0 of a linear polynomial. I am taking one example, a polynomial p of x, which is nothing but 3x minus 5. To find the 0 of the linear polynomial, we are supposed to follow 2 steps. Step 1, step 2. In the step 1, we will make the polynomial equated to 0. That means, let p of x is equal to 0. After that, in the second step, we solve linear equation in the second step. That means p of x is equal to 0 means here 3x minus 5 is equal to 0. Now we got a linear equation in one variable. That means a simple equation. Now we will solve by using transposition. Now here minus 5 in the left hand side, we will send it to the right hand side. Therefore 3x is equal to 5. Now 3 is multiplying in the left hand side. I am sending it to the right hand side. Therefore x is equal to 5 by 3. Here 5 by 3 is called the 0 of the linear polynomial 3x minus 5. Now we are going to find the 0 of a quadratic polynomial. I am going to take a polynomial p of x 3x square plus 8x plus 4. To find the 0 of a quadratic polynomial, we use splitting the middle term method. How to use that method means, first we have to compare the given equation with the general form of a quadratic equation. Compare with ax square plus bx plus c. We will get a is equal to 3 as they are x square coefficients, b is equal to 8 as they are x coefficients, and c is equal to 4 as they are constants. Now we are supposed to find the value of a into c, that is nothing but 3 times of 4, 3 4s are 12. Similarly, we have to take the value of b as it is, that is 8. To split the middle term, we are supposed to follow one new step, that is we are going to find 2 more new numbers in such a way that 2 more new numbers p comma q in such a way that the product of these 2 new numbers should be is equal to the product of the a and c. The sum of the 2 new numbers should be is equal to the value of b. The product of p and q should be is equal to the value of the product of a and c, that is equals to 12, and the sum of the two new numbers should be equal to the value of b, that is equal to 8. By taking the factors of 12 as 1 12 are 12, 2 6 are 12, 3 4 are 12, out of which observe this pair 2 and 6, 2 6 are 12, 2 plus 6 is 8. Therefore, the two new numbers are 2 and 6. To find the zeros, we will find the two new numbers first. After that, we will split the terms. The given polynomial is 3x square plus 8x plus 4. We will keep the first term as it is. In the place of second term, we will use this 2 and 6. That means 8x can be split into 2x plus 6x plus the third term, the constant is as it is, which implies from these two x is common. Therefore, from 3x square x is common means we get 3x. From 2x x is common means we get 2. Similarly, from these two terms we can take 2 as common. Out of 6 2 is common out means we will get 3 times of x plus from 4 we took 2 as common, so we will get 2. Now observe here 3x plus 2, 3x plus 2, which is a common here. By taking 3x plus 2 as common, we get x plus 2. As the polynomial is equated to 0, 3x plus 2 into x plus 2 is also equal to 0. The product of two polynomials is equal to 0. When it will happen, either the first term or the second term should be equal to 0. That means either 3x plus 2 is equal to 0 or x plus 2 is equal to 0. By solving this simple equation, we will get x is equal to minus 2 by 3. By solving this simple equation, we will get x is equal to minus 2. These two, minus 2 by 3 and minus 2 are called the zeros of the polynomials 3x square plus 8x plus 4. We will take one more example to find the quadratic zeros of a. We will take one more example to find the zeros of a quadratic polynomial. I am taking a polynomial p of x square minus 5x plus 6. We are supposed to split the middle term. First, we will compare the given equation with the general form of a quadratic equation, that is ax square plus bx plus c. By comparing the x square terms, we will get a is equal to 1. By comparing the x terms, we will get b value as minus 5. By comparing the constant terms, we will get c is equal to c. Now we are supposed to find the value of a and a into c, that is 1 into 6, 1 6 6, and we are supposed to take the value of b as it is, that is minus 5. Now we will find two more new numbers p comma q in such a way that the product of these two numbers should be is equal to 6 and the sum of these two numbers should be is equal to minus 5. By taking p is equal to minus 2 and q is equal to minus 3, observe the product of minus 2 and minus 3 is the value of 6 and the sum of these two terms is equal to minus 5. Therefore, the given polynomial p of x is equal to 0 means x square minus 5x plus 6 is equal to 0. By splitting the middle term here, x square as it is, minus 5x can be written as minus 2x and minus 3x plus 6 as it is. From these two terms, we can take x as common. From x square, x is common out means x will be left. From 2x, x is common out means we will get minus 2. From these two terms, we can take minus 3 as common. From minus 3 into x, we took minus 3 as common, so we will get x as it is. From here plus 6, we took minus 3 as common, therefore we will get minus 2. Check, minus into minus is plus, 3 2s are 6, which is equal to 0. Observe now, x minus 2 is a common here. By taking x minus 2 as common, we will get x minus 3, which is equal to 0. Observe here, the product of these two terms is equal to 0 means either x minus 2 is equal to 0 or x minus 3 is equal to 0. If x minus 2 is equal to 0, then x is equal to 2 by transposing minus 2 from LHS to RHS. Similarly, by sending minus 3 from LHS to RHS, we will get x is equal to 3. Therefore, 2, 3 are called the zeros of the polynomial x square minus 5x plus 6. The result is 4x square. By taking minus x as it is, we got a new dividend, that is 4x square minus x. Now the highest power term in the dividend is 4x square and the highest power term in the divisor is x. X will get cancelled. The new dividend is, the new quotient is 4x. 4x. Now multiply this divisor with 4x. X into 4x is 4x square minus 1 into 4x is minus 4x. Once again, by subtracting these terms, plus becomes minus, minus becomes plus. 4x square will get cancelled. Minus x plus 4x is plus 3x. By taking minus 3 as it is, the new dividend is 3x minus 3. Now the highest power term in the dividend is 3x and the highest power term in the divisor is x. X will get cancelled. The result is 3. That is your new quotient. Multiply now x minus 1 with 3. X into 3, 3x. Minus 1 into 3 is minus 3. By subtracting, plus becomes minus, minus becomes plus. 3x will get cancelled. Plus 3 minus 3 will get cancelled. Therefore, the remainder is 0. Therefore, by division algorithm, x cube plus 3x square minus x minus 3 can be written as the product of this divisor and quotient, that is x minus 1 into x square plus 4x plus 3 plus 0 as the remainder is 0. Now it can be written as x minus 1 into x square plus 4x plus 3. By splitting this quadratic polynomial into two more linear polynomials, we will get all the zeros. By taking the polynomial p of x is equal to 0, that is, the given polynomial is x cube plus 3x square minus x minus 3 is equal to 0. In the place of this one, we can substitute this one, that is x minus 1 into x square plus 4x plus 3, which is equal to 0. Now I am splitting this middle term by using the previous method, splitting the middle term method. X minus 1 as it is, x square as it is. Now I am splitting this one as 3x plus x plus 3 as it is, which is equal to 0. X minus 1 is as it is. Now from these first two terms, I am taking x as common. Therefore, I will get x plus 3. From these two terms, by taking 1 as common, we will get x plus 3. Which is equal to 0. As x minus 1 is same, from these two terms we can see that x plus 3 as common. Therefore, the result is x plus 1 is equal to 0. Here we got the product of three terms is equal to 0, which means either the first term should be equal to 0 or the second term x plus 3 should be equal to 0 or the third term x plus 1 should be equal to 0. If x minus 1 is equal to 0, then x is equal to 1. If x plus 3 is equal to 0, then x is equal to minus 3. If x plus 1 is equal to 0, then x is equal to minus 1. Therefore, here 1, minus 3 and minus 1 are called the three zeros of the given cubic polynomial. In this way, we find the zeros of the cubic polynomial. Now, we are going to find the zeros of a cubic polynomial p of x is equal to x cube minus 6x square plus 11x minus 6. Randomly, I am substituting here in the place of x 1. That means 1 cube minus 6 into 1 square plus 11 into 1 minus 6. 1 cube is nothing but 1 minus 1 square is nothing but 1. 1 6 are 6 plus 11 1 is 11 minus 6. 1 plus 11 is 12, minus 6 is minus 12. Therefore, 12 minus 12, which is equal to 0. Here, we got 0, means 1 is called 1 is called the zero of the polynomial p of x. Since 1 is the zero of the polynomial, x minus 1 is a factor of the given polynomial. Since x minus 1 is the factor, now divide this with this x minus 1 with the given polynomial, that is x cube minus 6x square plus 11x minus 6 divided with x minus 1. Now the highest degree term in the dividend is x cube. The highest degree term in the divisor is x. X cube by x is nothing but 1x will get cancelled, we will get x square. This is our new quotient, x square. Multiply this divisor with the quotient x into x square is x cube minus 1 into x square is minus x square. By subtracting, plus term become minus, minus terms becomes plus. X cube will get cancelled. Now minus 6x square plus x square is minus 5x square. By drawing this term, we will get plus 11x as it is. Now this is our new dividend. What is the highest degree power term here? Minus 5x square. What is the highest degree power term in the divisor? X. So divide with x. X will get cancelled. We will get minus 5x, which is our new quotient term, that is minus 5x. Now multiply this divisor with minus 5x. X into minus 5x is minus 5x square. Minus 1 into minus 5x is plus 5x. Now minus becomes plus, plus becomes minus, as we are going to subtract. Both minus 5x square and plus 5x square will get cancelled. Now 11x plus minus 5x. 11x minus 5x is 6x. By dragging this one, we will get minus 6 as it is. Now the highest degree term in the new dividend is 6x. And the highest degree term in the divisor is x. X will get cancelled. The result is x. That is our new quotient term. That is plus 6. Now multiply x minus 1 with 6. X into 6 is 6x. Minus 1 into plus 6 is minus 6. By subtracting, plus becomes minus, minus becomes plus. Plus 6x minus 6x will get cancelled. Minus 6 plus 6 will get cancelled. And the remainder is 0. Therefore, the given polynomial x cube minus 6x square plus 11x minus 6, that is nothing but our dividend, is nothing but equal to the product of the divisor and the quotient. That means x minus 1 into x square minus 5x plus 6. Now by splitting this quadratic polynomial into two more linear polynomials, we will get the three zeros. By taking the given polynomial as is equal to 0, that is x cube minus 6x square plus 11x minus 6 is equal to 0. In the place of the given polynomial, we can write the product of these two, that is x minus 1 into x square minus 5x plus 6 is equal to 0. Now we are splitting this quadratic polynomial. By keeping the x minus 1 as it is, I am splitting this middle term in such a way that, as we discussed in the earlier, minus 5x can be written as minus 2x, minus 3x and plus 6 as it is, which is equal to 0. X minus 1 is as it is, and from these two terms we can take x as common, we will get x minus 2. From these two terms we can take minus 3 as common and we will get x minus 2 is equal to 0. By observing this one, x minus 2, we can take x minus 2 as common there. By taking x minus 2 as common, we will get x minus 3 is equal to 0. Observe here, the product of three terms is equal to 0 means at least one of them should be equal to 0. That means either x minus 1 is equal to 0 or x minus 2 is equal to 0 or x minus 3 is equal to 0. If x minus 1 is equal to 0, then x is equal to 1. If x minus 2 is equal to 0, then x is equal to 2. If x minus 3 is equal to 0, then x is equal to 3. Therefore, 1, 2 and 3 are called zeros of the given polynomial p of x. This is the way to find the zeros of the polynomial for a cubic polynomial.